Title your notes, multiplying and dividing real numbers. And we're still on the same standard. We're looking at the additive inverse property. We're going to still use that. And we're also looking also into the math practice standard number 5 with the tools. Yes, sir? Are you repeating it? Yeah, here it goes. So our objective for today is I can multiply and divide real numbers. Let's read together. 1, 2, 3. I can multiply and divide real numbers. So our objective for today tells us that we're focusing still on the same concept. So what is my main concept still today? Yes?
I can multiply and divide real numbers.
That is the objective. But what is my concept? What is the main idea? Real numbers. So I want you to fill that in the Frayer model or the box. Put that in the middle. And let's see if you can remember the definition of real numbers. Don't look in your notes. See if you're from memory, you know it by now after I repeated it 1,000 times. No, I got it. Write it down, write it down. If you don't remember, start writing some examples of real numbers. Also, for non-examples, everybody look at me. Let's see if you remember. Don't say it out loud. Write it down, please, and then write your critical attributes. I'll give you guys about 40 seconds. Go. Okay, let's see. Let's see how close you came to the definition. We said that our term today, our concept, main concept is real numbers, and it should look something like this. The set of all numbers that can be represented on the real number line. Hands if you got that by yourself. Okay, not bad, not bad. Or something similar, Okay, not bad. So fill in the rest. The examples don't have to be exactly like the ones I have. As long as you have your own examples, I'm good with that. This is just so that you get familiar with the concept and with definitions. Okay. Okay. So once again, the set of all numbers that can be represented on the real number line. You got examples, non-examples. We said this one is called imaginary. Is that correct? Okay. And you wrote your critical attributes. Okay. So underneath that, you have some empty lines. Is that correct on your notes? We're going to write some steps right there. Okay. Here he goes. Write this down, please. Steps. Number 1, or you're going to write, to multiply and divide real numbers, I, step 1, identify if the result is a positive or negative. And how would we know that? In parentheses, you're going to write, if both numbers have the same sign, the result is positive. So step 1, identify if the result is a positive or negative. How do we know that? If both numbers have the same sign, the result is positive. So what if both numbers have a different sign? The result is what? Negative. If they have the same sign, it's positive. Different sign is negative. Step 2, compute the numbers. What does that mean? Multiply or divide. And step 3, simplify. Step 1, identify if the result is a positive or negative. How do we do that? If both numbers have the same sign, the answer is positive. Step 2, compute the numbers, which means multiply or divide. Step 3, simplify. Copy that, please. Now that we have our steps down, this will be one of the easiest classes forever of the school year. Okay? So check this out. Copy this down, example number 1. Copy that in the back. Example 1, find the value of each expression. We have 1a is 35 divided by negative 5. 1b is negative 11 times negative 4. And 1c is negative 6 times 7. Copy those and see if you can find me the product for those and quotient for those. Go. Number 1. Let me go over the steps to make sure we got our steps down. Step 1, identify if the result is a positive or negative. So are they the same sign? No, so it's a negative. Step 2, compute. What is 35 divided by 5? 7. Step 3, simplify. Can we simplify any more? No. So we're done with that. Number 2, identify if the result positive or negative. It's a positive. Compute. 11 times 4, that's 44. We can't simplify, so we're done. And the last one, identify the result is positive or negative. Negative. Compute. 42. Can we simplify? No. Now, check this out. The reason being that we're starting off with a sign so that we avoid mistakes. Who remembers last year or the previous years, focus please, that you actually took a quiz, per se, or a test, and all of a sudden you thought you did like really well, and all of a sudden you got it back and it's like, notes, you forgot the sign, right? You forgot the negatives, or you forgot to change the sign at the end, or whatever the case. Why? Because you focused too much on the computation part, and you try to finish, and you forgot about the little sign. That's why we're doing that at the beginning. Does that make sense? All right, let's continue. Copy this down, please. Example 2. It says, find the value of each expression. A is 1/2 times negative 10. B is negative 48 over negative 4. Go. Let's see what we got. For number 2A, for these, whenever you multiply a fraction times a whole number, make sure you write the whole number as a fraction. Step 1, identify if the result is a positive or negative. This is a negative. Step 2, compute. 1 times 10 is 10. 2 times 1 is 2. Step 3, simplify. This becomes negative 5. Hands if you got that. Good. Number 2B, identify if the sign is the same, or identify if the result is a positive or negative. So this is a positive. 48 divided by 4, that's 12. We can't simplify, so we're done. Hands if you got both of them correct. Okay, let's continue. Copy this one. You have 25 seconds. Negative 3 times 2/3. So yeah, so for this one, once again, over 1, this becomes a negative. 2 times 3, that's 6. 1 times 3, that's 3. Simplify, that's negative 2. So far, so good? Copy this one down, please. Example 3Q. Negative 7 times 5 over 7. See what you get. Go. Correct. So once again, check this out. This is over 1. Identify if the result is a positive or negative. It's a negative. Compute. 7 times 5, that's 35. 1 times 7 is 7. And this is negative 5. Let's do another one. Example 3, super Q.
No, Mr. Q is 10Q.
No, super Q. Let's do negative 9 times negative 2 over 9. 15 seconds. On 3, everyone. 1, 2, 3. 2. That is correct. 2. So this is over 1. The correct answer for these is a positive. This is 18 divided by 9, and this is 2. Are we there so far? Yeah. Okay? So, with that said, let's continue. Now, on the Q side of your notes, go to the back side again. Go to the Q side. I want you to copy the first sentence. It says, 2 numbers are reciprocal if their product is 1. What does that mean? If you multiply 2 numbers and the result is 1, then they are reciprocals. Let me cover this. And then I want you to draw an arrow coming out from reciprocals and write somewhere on your paper this term, multiplicative inverses.
What?
Multiplicative inverses. So what does that mean? Reciprocals are also known as multiplicative inverses. Reciprocals are 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 multiplicative inverses. multiplicative inverses. Reciprocals are multiplicative inverses. Reciprocals are multiplicative inverses. Reciprocals are multiplicative inverses. So next time you see the word reciprocals, you think about multiplicative inverses. So what does that mean? Let me show you really quick. Here we look up. If we have 4, the reciprocal of 4 is 1 over 4. Because it says here that their product has to be 1. Pay attention to this. That means that the answer has to be 1. Let's see. How do I do this? Times 4 over 1. This becomes 4 over 4. And what is 4 over 4?
1.
1. So their product is 1. That's why this is a reciprocal of that. Let's do another one. How about 7? Think about it. What would be the reciprocal of 7 that gives me 1? Taylor. 1 over 7. That gives me 7 over 7, which becomes a giant 1. Let me show you another one. 2 over 3. Think about it. What would be the reciprocal? Tell your neighbor, please. So, what is the reciprocal of this one? 3 over 2. Why? Because 2 times 3 is 6. 3 times 2 is 6. And that is still a giant 1. So far, so good? So once again, that's the reciprocal or the multiplicative inverse. We got that? Okay. So now, think back to when you were in elementary. Okay? Let's see. In elementary, your teachers, when you got to dividing fractions, they taught you a process. Think about it. Don't say it out loud. That process involved 2 fractions and with a division sign, and they said, keep, change, flip, or change. Some use it as keep, change, or keep, change, flip. Who remembers that? Yes? Okay. But the question is why? Yeah.
Like, they need don't they need, positive and negative, keep the process?
No, they just gave you a process. Why? They never told us, right?
No.
This is the year of the why, so check this out. Pay attention, please. I'm going to go over this really quick. Pens down, eyes up here. Here it goes. So, here's a definition of quotients. You're saying, whoa. The Q stands for quintani. No. Yeah. It stands for quotient. Quotient means the result of a division. But Q also stands for a rational. Rationals are basically fractions. So you see a fraction here. M over N. Do you guys see that? Okay, so this is the actual definition for fractions or rationals. Here it goes. It says, pay attention. Quotients or rationals are the set of M divided by N, or the fraction M over N, where M is Z. What does Z stand for? Z is an integer. Does that help? Let me read it again. Fractions or rationals are the set of all M over N, where M is an integer, N is an integer, but N cannot equal to 0. Once again, M and N are integers, but N cannot equal to 0. Are we there so far?
Yeah.
Okay? So that's the actual definition for rationals. Now let me show you why this matters when we do dividing fractions by fractions. Here it goes. Pay attention, please. If we have these two, this implies this. Right? Do you agree?
Yeah.
This divided by this is the same as writing it like this. Is that correct?
Yeah.
But doesn't it look kind of funky? It looks kind of weird, right? But why? Look at the definition. Once again, what is N? An integer.
Oh.
And what is this?
Maybe.
This is not an integer. It's a what?
Fraction.
It's a fraction. So according to the definition, this cannot be right there. Is that correct?
Yeah.
So what would be the easiest integer that we can think of? Yes. The easiest
Q.
integer.
Oh, integer.
The easiest one, the easiest.
Negative.
Easiest integer.
1.
1. There it is.
What?
There's a 1. Do you guys see it?
Yeah.
Okay. So how can we make, think about it, how can we make this 1/2 into 1?
Oh.
Take a little bit of time to think about it. Hint, we just took notes right now about it.
Look at your nose. That's cute. How do you have
Yes. Which is what? What is it called? Put a fraction beside it, which is called the reciprocal. That is correct. We multiply times the reciprocal to make it 1. Is that correct? Yeah. So, now that we have an integer here, but we already multiply this by 2 over 1, what do we need to do up here? Multiply times 2 over 1, because whatever we do here, we do there. Are we there so far? So now check this out. What is all this divided by 1?
1.
All this divided by 1 gives us this same thing. Is that correct?
Oh, yeah.
Yeah.
Watch, I'm going to write it here. This divided by 1 gives us that, right?
Yeah.
Look what I just did. Watch. The old keep, change, flip.
Wow.
Oh, that was good.
Right? It's like,
Yeah.
that is the why behind we keep, change, and flip. Basically, because the definition does not allow us to have what? Fractions in the denominator. What does it need to be? A integer. Are we there? Okay. I'm not going to go more into this. Now that we know the why, now let's get some work done. Let's copy this next one down, please. Here we go. Yeah. Example number 4. Divide negative 1/2 divided by negative 5 over 6. Negative 1/2 divided by negative 5 over 6. So the first thing we're going to do, we're going to rewrite this. Let's do this one together. The first fraction stays the same, so keep the first fraction. Change from division to multiplication. And then we write the reciprocal. What is the reciprocal of negative 6 over 5? And now we use our 3 steps that we learned. Step 1, identify if the sign of the result is a positive or negative. It's positive. What is 1 times 6? 2 times 5? 10. Last step, simplify. What is the simplification of this? 3/5. Okay? Are we there? Let's do another one. Example number 5. Copy this one. For this one, before you do the entire process, change this mixed number into an improper fraction, please. Go. You got 25 seconds. Okay. So the first one stays the same. 8 over 9. We change division to what? Multiplication. Then we need to write the reciprocal, but before that we need to rewrite this, right? This becomes negative 3 times 2 is 6 plus 2, that's 8 over 3. What is the reciprocal? Negative 3 over 8. So, what is the result? It's a negative. From there it's 24 over 72. What is our last step? Simplify. So this becomes negative 1/3. Hands if you got that by yourself. Okay?
I have a question.
So, shoot.
Shouldn't the negative be a positive since you have to change, since it will be a positive?
Let's see. I said first we need to rewrite this, right? This became negative 8 over 3. What is the reciprocal? Negative 3 over 8. So now look at these two. Are they the same sign?
No. Shouldn't the negative on 8 over 3 or 3 over 8? It's gonna be positive?
Flip it, you don't change it.
No, you're just getting the reciprocal.
No wonder I failed everything fast.
Okay? So, any questions with this? Fairly simple, right?
Yeah.
Okay, now the only thing I want to get to after this is properties of zero. So pay attention. Pens down, eyes up here, please. There's three basic properties. Pay attention, please. Here he goes. The first one, when we multiply by zero, or we call it the zero product property. What does that mean? That any number times zero, the answer is zero. Straightforward. There's no ifs or buts about it. It's that simple. Any number times zero, the result is zero. Are we there so far?
Yeah.
The second one is also very similar. Look at this one. It says 0 divided by a number. When you divide 0 by any number, the answer is 0. Very similar to the multiplication one, right?
Yes.
But this is the one where some of you get confused. When you have division by 0, when you get a number and you want to divide by 0, that becomes undefined. Now let me show you why. Pay attention, please. When we have, let's say, 7 divided by 0, what do you notice? Where's the 0 at? In the denominator. Yes? And what did we say about the definition? What did it say? That n cannot equal to
And
0. And where's 0 at? In the denominator. That's why this is called undefined. This is the only time it will be undefined. Okay? Okay. So those are the three properties that I wanted to introduce. So check this out. Everybody look up. Look at this one. 0 is being divided by a number. Is that possible? Yes. So the answer is 0. 0 is being divided by 0. That means a number divided by 0. What is this one?
0.
No, this
One.
is undefined. And this one, they're multiplying times 0, so the answer is 0. Okay? Also, last one. When we have rate problems, remember to write distance equals rate times time. And here, all we have to do is write our information. Focus, please. What is our rate? 3 3/4 times, what is the time? 1 1/3. And do we know what to do from there? Yes. Make these in proper fractions, multiply and simplify. Are we there? Our homework for the weekend, guys, is worksheet 1.3, and it's over there by the coffee maker. Make sure you turn in your other one in on your way out. Have a good one, guys. Enjoy your 3-day weekend. See you guys till Tuesday. Yeah, we have a 3-day weekend. Yay. Bye. Have a good one.